Hello, hi dear students. Welcome to Karnataka SLC online. So in the last video, I have asked one question, okay, and for that some students have given correct answers, and in this video I'll just explain about the answer, and we will continue with the next chapter, which is polynomials. Okay, see, it was a 10th question. So the two numbers were given, and they told the HCF is 81. Okay, HCF is 81, and after solving we got x plus y equal to 15, and the question was how many such pairs of numbers we get for x and y. So the list goes like this: 1 comma 14, 2 comma 13, 3 comma 12. Okay, so there are so many combinations which gives addition to be 15. But you need to understand, when HCF, okay, when they say HCF is 81, okay, the x and y should be co-prime. They should be co-prime. There should not be any other common factors. Suppose if I take 3 and 12, there is again common factor 3. HCF is 3. So in that case, HCF is not going to be 81. It is again 81 into 3. Okay. So when HCF is given, the x and y should be co-prime. So you need to select the only co-prime pairs among the given option. So here it is 1 comma 14, 2 comma 13, 4 comma 11, and 7 comma 18. So for these 4 pairs, okay, so the HCF is going to be 1. You can see 1 and 14 HCF is 1, 2 and 13 again HCF 1. So HCF is going to be 1 when the two numbers are prime. Okay, I mean maybe prime, may not be prime, but here the HCF should be always 1. So 1 comma 14 same, 2 comma 13 again, 4 comma 11, and 7 comma 8. Okay, so they are actually co-prime numbers. So co-prime numbers means you will get HCF 1. So that is why we will get only 4 combinations. Okay, so we'll continue with the next chapter. Okay, today we'll start with the next chapter called polynomials. Okay, so in this chapter, okay, so what are the things a student need, okay, in order to understand the questions is, you need to know what are called the zeros of a polynomial. Okay, and you also need to know the relationship between zeros and coefficients. Okay, so what do you mean by zeros of a polynomial? Okay, see, first thing, polynomial. Okay, so when you consider polynomial p of some function x, okay, so polynomial can be a linear polynomial as ax plus b. Okay, a polynomial can be quadratic, okay, ax square, okay, plus bx plus c. Okay, and a polynomial can be, we can write even ax to the power n. Okay, so for such a polynomial, the degree will be, okay, the degree will be the highest power for the x. So here the highest power is 1 means, so the degree is 1. Here the degree is 2, and here the degree is n. So the highest power of n will give you the degree of that polynomial. Okay, so here these polynomial have only one variable. Okay, but when you consider zeros of a polynomial, you can find zeros of a polynomial. For example, for linear polynomial, you can equate it to 0. Okay, so the x value will be minus b by a. Okay, so this particular value of x, we call it as a. Okay, we even call it as a. Okay, so here x value takes minus b by a. Okay, so here 0 means the factors will give you the zeros of a polynomial, and the values when you put in the equation, when you put in the polynomial, that polynomial should give you the answer as 0. Okay, so such values are called zeros of a polynomial. For example, I'll take simple linear polynomial as a 2x plus 5. Okay, it is a linear polynomial, and I want to find the 0 of this polynomial. It means for what value of x this polynomial, I mean this expression gives you 0. Okay, for that you can equate this to 0. So it is 2x equal to minus 5 and x equal to minus 5 by 2. Okay, so in the place of x, if you put minus 5 by 2, this polynomial is going to be 0. So for this particular value of x for which the polynomial gives 0 is called a 0 of a polynomial. Okay, this is for linear. And if you consider for quadratic, okay, so for quadratic if you consider, okay, so for quadratic you have two factors. Okay, from each factor you will get 2 zeros, alpha and beta. You will get 2 zeros, alpha and beta. Okay, so for alpha and beta, the quadratic equation will give you 0. After putting alpha value and similarly beta value, the quadratic expression will give you 0. So such values are called zeros of a polynomial. Okay. Next, we also need to know the relationship between zeros and coefficients. Okay. We know the general form of a quadratic equation. Okay. So it is ax square, okay, plus bx plus c equal to 0. It is general form of a quadratic equation. Okay. And if you are able to identify the coefficients, okay, and if you are able to find its factors and then zeros, then we can make a relation. Okay. See, what are the coefficients here? See, x square coefficient you can write a, okay, coefficient. Okay. Then x coefficient b, and c is a constant. Okay. This is one part. Next, I'll find the zeros, nothing but the roots. Okay. So for this, if I find roots, okay, the roots can be, okay, alpha and beta. Okay. First I'll find two factors. From each factor I'll get one root. Okay. It means I'll get a total two roots. Roots are also called to be zeros. Okay. So I'm getting two zeros when I solve this by factorization method, and I can also identify the coefficients as a, b, c. Okay. Now I can make a relation between these coefficients and zeros. So these are nothing but coefficients. Okay. These are coefficients. Okay. Coefficients. And these are nothing but our zeros. Okay. The relation is such that, okay, so sum of zeros you can relate with the coefficients as minus b by a. Very important. Okay. So when you find zeros or roots, that you can relate with the coefficients as minus b by a. Okay. In terms of words, if you write a minus b indicates a coefficient of x. So it is coefficient of, okay, coefficient of x divided by a stands for coefficient of x square. So it is coefficient of x square. Correct? Next, even you can make use of zeros as alpha into beta. So the product of zeros also can be related with the coefficients. How? It is c by a. It is given to be c by a, where c is a constant. Yes, c is constant, fixed value. Okay, divided by a, nothing but the coefficient of x square. So coefficient of x square. Okay. So this is an important relation between, okay, between the coefficients, okay, and the roots or zeros. Okay. So you need to remember the basic idea. Okay. What is called to be polynomial, how to find zeros of a polynomial, and relation between zeros and the coefficients. Okay. So next we will go with the questions. Okay. Yes. First one. Which of the following is a 0 of p of x, which is equal to 2x square minus 5x plus 3. Okay. So this is a polynomial of function of x. Okay. This polynomial varies with respect to the values of x. Okay. And they're asking which value among these four will give you 0. Okay. After putting any of these values, the polynomial should give you 0. Okay. So here no need to find its factors. Okay. So you just put these options in the polynomial, and the option which gives this polynomial value to be 0, that is called the 0 of a polynomial. Okay. So already write. So the given polynomial is 2x square minus 5x plus 3. Okay. This is a polynomial. Okay. We'll check with first a value. Okay. Now for, okay, x value I'll take minus 1. If I take x value minus 1, so it is 2 of minus 1 square minus 5 of minus 1 plus 3. Okay. Yes. So this is 2 minus 1 square means minus square plus 1 square 1. So 2 into 1 minus into minus plus 5 into 1 5 plus 3. Okay. So it is 2 plus 5 plus 3. Okay. So it is going to be 10. Now is 10 equal to 0? 10 is not equal to 0. So you should get 0 after simplification, then only such value is called to be 0 of a polynomial. But here we are getting non-zero value, so it is not the option. So we'll go with next option for, okay, for x equal to 2. for x equal to 2. Yes, so 2 of 2 square minus 5 of 2 plus 3. Okay, now 2 square 4, 4 into 2 8, minus 5 into 2 10. Okay, plus 3, 8 plus 3 11, 11 minus 10, you are getting 1. Again 1 is not equal to 0, so it is not your answer. I'll go with the next option for x equal to 3 by 2. Okay, yes, 2 of x value 3 by 2, okay, square minus 5 of 3 by 2, okay, plus 3. Okay, so 2, 3 square 9, 2 square 4. I can put into because of bracket. Okay, minus 5 into 3, okay, 15 by 2 plus 3. 2 times 1, 2 times 2, it is a 9 by 2 minus 15 by 2 plus 3. Okay, now they are like fractions, so you can add 9 minus 15 minus 6 by 2 plus 3. Now minus 6 by 2 is nothing but minus 3, so minus 3 plus 3 is equal to 0. Yes, so in this given polynomial, okay, if you put x value as 3 by 2, this complete polynomial is going to be 0. Okay, so this value x equal to 3 by 2 is called a 0 of a polynomial. It is called a 0 of a polynomial. Okay, this is one of the 0 because it is a quadratic mean, so you will get a 2 zeros, but here we have given 1 0. You can even find the other 0 by finding its factors. Okay, now second one, which of the following is a polynomial? Yes, again it's a very basic question, so we need to know that the basic definition of a polynomial, which terms are called to be a polynomial. We know that it should have a constant and it should have a variable. Okay, but what about the power of the variable? Okay, see, as per the polynomial, okay, suppose if I consider x power, okay, x power, some power, this power should not be, okay, should not be negative. Okay, it should not be negative. Okay, and it should not be fraction. It should not be fraction, or even you can say it should not be decimal. Okay, these things should not be there for x power. Okay, if it is so, such expressions are not called to be polynomial. Okay, yes, we can see. So the first option, if you see x square, okay, it is an integer. Okay, no problem. X to the power 1, okay, it is okay. But here what about the root of x? Okay, a root of x means you can consider, okay, root of x. Okay, so root of x indicates x to the power 1 by 2. So 1 by 2 is a fraction, or even you can consider as a decimal. Okay, so such powers are not called to be polynomial, irrespective of other terms. Okay, so option A is not going to be a polynomial. Okay, second one, root 2x square minus 5x plus 3. Here we have root. Here a root we have for the number, not for the variable. So we have an integer part only for x. So we have x square. Okay, we have x square minus 5x plus 3. Okay, so here x power is an integer. Okay, plus 2, and here x power is 1, again an integer. Okay, so such values, okay, if such powers are considered to be polynomial, it means your correct option is, okay, option B. Okay, and it is very obvious for option C. We have 3 by 2, 1 by 2, say, so they are in fraction form. If power is fraction form, they are not a polynomial. And even option D also you can see, root of x means, root means 1 by 2, again it's a fraction. So the A, B, C, they are not polynomials, only option B is called to be polynomial. Okay, so you need to remember this one, the power should not be negative, decimal, or a fraction. Okay, fine. Next one. Yes, the zeros of the polynomial p of x equal to 4x square plus pi root 2x minus 3. You need to find the zeros. Okay, again, so the given equation is 4x square plus pi root 2x minus 3. Okay, you need to find the zeros. So when we need to find zeros, you can equate that to 0. Okay, now you can make use of a into c, okay, to get the factors. Okay, so a value 4 and c value 3. Okay, a value 4, c value minus 3. Okay, so you need to go with a into c. Okay, so a into c, okay, it is going to be minus 12. Okay, now you need to write two factors. Okay, and remember both the factors must have a root 2. Okay, so both the factors must have a root 2. That is the idea. Okay, now root 2 into root 2, root 2 into root 2, you will get 2. You will get 2. Now to get 12, you need 6 into 6. Correct? Huh? Now to get 6, you have a combinations. Either you can make use of 1 and 6. Okay, 2 and 3. Okay, so which combination will give you the correct answer? Means multiplication should give minus 12, addition should give 5 root 2. Okay, suppose if I add 1 and 6, 1 and 6. Okay, however multiplication will give you 12 and I need minus sign. Okay, so and I also need a plus 5 root 2. Okay, so if I add, I'll get 7 root 2. Okay, so to get plus 5 root 2, I'll make 6 root 2 as it is a bigger number, I'll make it a positive and this one as a negative. Okay, so if I add, I'll get 5 root 2. If I multiply, I'll get a minus 12. As here it is minus, any one term must be minus. Okay, so with this combination, I'm getting the correct answer. But if you change to other combination like 2 root 2 and 3 root 2, okay, multiplication will give 12. If I make changes either to left side or, okay, if I make change here minus, so addition will give plus 1 root 2. So if I make plus and this as minus, addition will give minus root 2. However, I may get minus 12, but at the same time both conditions should satisfy. So this combination is false. Okay, so I can go with the minus 1 6 root 2. Okay, so I'll split this one as 4x square. Okay, I'll write first 6. Okay, 6 root 2 x. You can write in any order, no problem. Okay, 6 root 2 x and minus 1 means I'll write root 2 x minus 3 equal to 0. Now what is common? So 4 means 2 into 2 you can write. So I'll write 2 into 2. Okay, x square and this one 3 into 2 root 2. Okay, x minus, here nothing is common, you can take 1. Okay, so it is root 2 x minus 3. Okay, so we know what, so the common, the factor what you're getting here, the same factor you should get here. Okay, that is the idea. Okay, so here what is common? 2 is there, 2 is there, and for this 2 shall I write as again root 2 into root 2 because we have a root 2. So 1 2 I write as it is, the next 2 I'll write it as root 2. Okay, into root 2 x square plus 3. Okay, plus 3 into 2 root 2 x minus 1. Okay, root 2 x minus 3 equal to 0. Fine. Now in these two terms, what is common? Is it 2 root 2 x? Okay, 2 root 2 x. Okay, so what is left? 1 root 2 x plus 3 I got minus, okay, 1 you can neglect even, no problem. So root 2 x minus 3. Okay, remember I told you the factor what you get in the first part, same you should get in the second part, or when you get in the second part, same you should get in the first part. Here the thing is we are getting same term but a different sign, so somewhere we did mistake. So you can cross verify. See, here I took minus 1 common. If you open the bracket, minus into root 2x minus root 2x, minus 1 into minus 3, it should be plus. Okay, here we actually it should be minus, but here we are getting plus means make it plus. Now it is verified. Minus 1 into plus 3 is minus 3. So I'll pick plus. Yes, now the factors are exactly same. You can equate it to 0. You can equate to 0. Okay, so now we can again make common root 2x plus 3, root 2x plus 3. Okay, so it is root 2x plus 3 one factor. So the other factor is 2 root 2x, okay, minus 1 equal to 0 is another factor. So you can equate each, okay, to 0, each factor to 0. Now x equal to plus 3 other side minus 3 by root 2, and here x equal to minus 1 other side plus 1 by 2 root 2. Okay, so these are the two zeros. It means for these values, see, we're getting minus 3 by root 2 and 1 by root 2. So we don't have that answer here. So we will go with the rationalizing. Okay, so we will rationalize. So rationalizing this, so it is minus 3 by root 2. So you can multiply root 2 and root 2. So you'll get minus 3 root 2 by root 2 into root 2 will get 2. Minus 3 root 2 by 2, one of the factor, and other factor, okay, again 1 by 2 root 2. Again you can multiply with the only irrational number. So you'll get x equal to numerator root 2, denominator 2 as it is. Now root 2 into root 2 you'll get 2. So the other factor is going to be root 2 by 4. Root 2 by 4. So I think it is option C. It is option C. Okay. Fine. So this way you can understand what are called to be zeros and how to find the zeros of a polynomial, okay, and how to find the factors of a polynomial. Okay, so in this video this much, and in the next video I'll bring some more very important questions and those questions are related to even a graph, okay, and making an equation, okay, quadratic equation from given zeros, okay, and with the help of even coefficients also you can make a quadratic equation. Okay, so that we'll study in the next class. Okay, so keep supporting. Okay. Okay, fine. So we have one more question, sorry. Fine. So number of polynomial having minus 2 and 5 as their two zeros is, okay, so there is a polynomial and it has a two zeros, minus 2 and 5, and here how many polynomials can make the zeros as minus 2 and 5? Okay, so for that what you need to understand, first you find the sum of zeros and the product of zeros. Okay, as they have given two zeros, okay, so I'll find the sum of zeros. We know sum of zeros alpha plus beta. Okay, so it is minus 2 plus 5, you will get a 3. Okay, and the product of zeros which is c by a, isn't it? So here it is a 5 by minus 2, so minus you can take to the numerator, it is minus 5 by 2. Now we know the standard form of a quadratic polynomial with the help of the zeros. Okay, the standard equation, okay, the standard equation is going to be k into, okay, going to x square minus, okay, alpha plus beta x, okay, plus alpha into beta, okay, equal to 0. Okay, so if I put the values, k some constant as it is, x square minus, okay, alpha plus beta, you will get 3, okay, 3x plus, okay, alpha into beta minus 5 by 2, minus 5 by 2. Okay, so it is going to be 0. Okay, now you can see correct, alpha into beta, oh sorry, alpha into beta, okay, we'll see the next question. Next one, the number of polynomial having minus 2 and 5 as there are two zeros is, okay, so here they are given two zeros, okay, and how many polynomials are possible where the zeros can be again minus 2 and 5 only. Okay, so what we do, so as two zeros are given, we will represent these as alpha and beta. Okay, and we will also find sum of zeros and product of zeros. Okay, see, so first I'll find I'll find, okay, sum of zeros, alpha plus a beta. Okay, so it is minus 2 plus 5, you'll get a 3, and alpha into beta, okay, alpha into beta, so it is minus 2 into 5 minus 10, because they told these are the, I mean, minus 2 and 5 are the two zeros. Two zeros means you can take one zero as alpha and other zero as a beta. Okay, now we know the standard form. Okay, standard form of quadratic equation. Okay, standard form. Okay, so standard form we know. Yes, what is standard form? It is x square minus alpha plus beta x plus alpha into beta, okay, equal to 0. Okay, and this should be multiplied with some constant k. Okay, so here k, x square minus sum of zeros, we have got 3x plus product of zeros, we have got minus 10, okay, equal to 0. Now we can observe here k can take any value. Okay, k can take any value. It means, suppose, see, this is a quadratic equation, means you will get two zeros, one as a minus 2 and other as a 5. Okay, suppose if k take k value is 2, okay, k value is 2, okay, k value is 2, okay, so you will be getting, okay, 2x square, okay, minus 6x minus 20, okay, minus 20 equal to 0. Okay, so even if you solve this again, you will get same zeros, minus 2 and 5. Okay, so as k is here, so we will get more other you will get other possibilities. Okay, you will get other polynomials whose zeros are again minus 2 and 5. Okay, if you solve this, you will get again zeros, minus 2 and 5 only. Okay, so there are many ways you can make the polynomials whose zeros are going to be again minus 2 and 5. That is because of k, some constant. Okay, so here how many possibilities? Okay, so the number of possible polynomials is going to be, yes, it is infinite. It is infinite. Okay, fine. So these are some of the important questions related to polynomials. Okay, so in the next video I'll bring some more very important questions. Okay, and there we will try to learn about representing zeros on graph. Okay, and converting the given zeros into an quadratic equation. Okay, identifying the zeros. Okay, identifying the values given. Okay, like they will give some they will give sum of zeros and product of zeros. From that we need to make a quadratic polynomial. Okay, so all those things we'll study in the coming classes. Okay, so keep supporting, keep sharing. Okay.